Hi, in this video I'm going to go through the questions from the Week 5 logic and loop script that we just didn't have time to go through in class. So for the record, most of these questions that are present in this file do have examples down at the bottom of the script. So you just have to scroll for a bit or just come to this handy dandy table of contents. So I'm going to collapse that just so that we have more room to look on the screen. Make my screen a little bit bigger, actually. If I can. Yep, there it is. And let's go through it. So it says, change the code below so that it correctly reports if x is even or odd. So here's 10, creating a value of x called, that stands for 10. Then this is going to divide by 2 and return the remainder. That's what modulo does. It's the %%. So in this case, it says if y equals 0, then print x is even or odd. Well, if x is, if y is 0, then x must be even. If x is not 0, which is when this code would get run, it must be odd. So if we run this now, we get that y is not created because I haven't run y yet. X is even, that's correct. If I change this to an odd number, y is now 1. This is no longer true. And so x is not odd. Easy enough. Write logic that prints a message when x divided by 3 has a remainder of 1. So if I say, I don't know, let's just put some test code here so it's a little bit easier. So if x divided by 3 has a has a remainder of 1. Order of operations means that this will actually occur, I believe, this way, but if I wasn't confident in that, I could add some parentheses just to make myself more confident. In the end, this should resolve to some sort of logical object. It does. X currently does not have a remainder of 3, so this does not should not do anything. Print x divided by 3 has a remainder of 1. So if I do this, nothing gets printed. That makes sense. If x is 4, however, that should be true. If x is 5, that should not be true. 6, that should not be true. It all checks out, and that makes sense. Write a logic message that prints when x is divisible by 2 and or if x is divisible by 3. Interesting. So I could write all of that in one go. I could also customize my response. So let's try both. When x is divisible by 3, so is divisible, so that's going to have a remainder of 0, or so cool. And so x is divisible, should probably make that a lowercase x. Divisible by either 2 or 3. And then I wanted to also print off a message if either of those tests are false. Now that's kind of fun because that's a separate test. If I just put an else, then it would only print a message when both are false. So if I could write it from like the standpoint of true by changing this. Just bear with me while I type here, just to show you kind of my process. Right now I haven't changed anything, but if I change to not 0 or not 0, I would have now is not divisible by, I guess, at least 2 or 3. So let's try that. X equals 1. Not divisible by 3, not divisible by 2. I should get this message to print. I should not get this message to print. Correct. 2, I should get this message to print. I should also get this message to print. That is what happened. 3, same thing. And if we do a common denominator, or what is this, a common multiplied, I don't know, a common multiple, there it is, common multiple of 3 and 2, so 6 is one of those. We should get this top message, but not this bottom message. And that's true. That's actually how you could write a function that detected common multiples, or at least the start of it. So that's all I had for the logic section. If I scroll down to the loop practice, this one doesn't have answers. You have to go to this page, but I'll just put answers here. Write a for loop that iterates over the numbers 1 through 7, and then prints the cube of each number using print. So it looks like I left my answer in there. Whoops. 1 through 7, so I in 1 through 7. Print I cubed. Easy enough. Write a for loop that iterates over the column names of the inbuilt iris dataset and print each together with the number of characters in the column name in parentheses. Example, sepal.length followed by parenthetical 12, which is the number of characters in the column name. So here I'm going 1 through the number of columns. And that's because my preferred way of utilizing for loops is to reference the position within the object I'm trying to like loop across. It's by far the nicest way to do this. I have often reached the end of an analysis where I just like made this object on the right the column names of iris, and I was just each of the column names, so essentially what becomes current call here. But it's very commonly ends up running into a wall when I want to do things like save the output and stuff like that. So my general recommendation, just as a strategy, is start using this, a kind of position-based reference that you use this iterated vector for. So anyways, when I run this, for will create an object called I, overriding it. If it was already there, it will set it equal to each value in 1, 2, 3, 4, and 5. So 1, then 2, then 3, then 4, then 5, each time running this piece of code. So when I is 1, and I can make that true manually so that I can kind of test out stuff, I need to iterate over the column names of iris. So here I am extracting the ith, is how I would often refer to that, the ith column name, and saving that as a object called current call. I then use the inchar function, in number of characters function, save that as current inchar. Finally, I assemble this data into a single object using paste O, which is just a very handy tool, and then I print off that value. This will repeat for each of the values in 1 through in call, so you can watch this happen now. Now, please note, it is going to start over because, as I said, it creates and overwrites any pre-existing version of I. Just a very important thing to keep in mind. Additionally, since it created an object, and it did this in my what's called a global environment, I is now 5. So that worked. Write a while loop that prints out standard random normal numbers, but exits the loop when you get a number bigger than 1. So it's saying that x is greater than 1. X is going to be set equal to 0 to begin with, just so that the while loop begins. The while loop will continue as long as this remains true. So right now it's true. It's still true, still true, until I change the value of x. That won't happen. But inside of here, I am generating one normal value from the standard normal distribution, which is a mean of 1 and a mean of 0 and a standard deviation of 1. It's going to generate that. Right now it's negative 0.92. It's going to print that value, and then the loop restarts. It checks its logic. That's still true. It runs this. Still true. It's going to keep going then. Still true. Let's just let the while loop run now. So it took a few tries, but eventually it generated a value greater than 1. That doesn't run anymore because if I tried running it again, x is currently currently greater than 1. If I reset x though and run it again, it took 3 tries. Quite a few more tries. So this is just a random chance that eventually this happens. The next one says, write a for loop that adds the next 5 values of the Fibonacci sequence to x. So this is starting off with these values. So if I say for I in, I guess 5 more values. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just going to be 1 through 5. The Fibonacci sequence is you take the previous 2 values and you sum them together to give you the new value. So I guess we'll call new val. And we're going to have to calculate where we are in this. So I guess I will say the length of x minus 1 through the length of x. Now, order of operations here is not your friend. This would have generated 1 through length of x without the parenthetical. But now should get, once I've created x, I should get 4 through 5. So this is going to get those, and then I just need to sum these values. Then add that new value onto x. And overwrite x so that it builds as it goes. So let's run that again. This loop has run. 1. Those 2 added together was 2. These 2 added together was 3. These 2 added together was 5. These 2 added together was 8. These 2 added together was 13. These 2 added together were 21. And we succeeded. It was 1, 2, 3, 4, 5 new values. If I wanted to have seen what that looked like as it was going out, because I was just, learning and trying to figure out what's happening, I could generate a printed out object by just calling the print function. Now, please note that inside of a for loop, you do in fact have to call print manually. So without calling print, it's not showing it. Okay, that's it. Hopefully that helps. Please keep at it. There's lots more practice on these sections. For loops are crazy powerful. It was a way that I really upped my game when I was first learning to code, because it just made analyses that were too difficult for me to conceptualize, like without doing it one row at a time or one value at a time. It made it much more understandable. So hopefully that helps. Sorry, my voice sounds like I ate a frog.